In this section, we will look at set operations. So things like union, intersection, complementation, difference. Then we will look at set cardinalities, set identities. Set identities is something you will already learn in section 1.3. Let's look at the first set operation, which is the union. So the definition of the union is let A and B be sets. The union of sets A and B, denoted by A union B, is the set that contains those elements that are either in A or B or in both. What this is basically saying is all the elements of A and B or both combined will be your union. For example, let's say you have these two sets. Set A has 1, 2, 3 and set B have 3, 4, 5 as its elements. So what would be the union of these two sets? So which would be everything? Let's put these values in the Venn diagram. So set A will have value 1, 2, 3. So it could be like this. And set B have the values 3, 4, 5. So 3, 4, 5 will go in here. And notice we have 3 common in both sets. Here there's a 3, here there's a 3. And you might have some other numbers which we are not concerned with. 8, 6, 9. Those are outside of the set A and set B. So for your solution would be A union B would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And even though you have 3 in both sets, you only count it once. So no duplicates. So that's why I got 1, 2, 3, 4, 5. 3 is not repeating. Another thing I want to introduce is inclusion-exclusion formula. So this is another way you can come up with the A union B. So here I'm using cardinalities, but let's see here, this is set A. So I know my set A has the element 1, 2, 3 plus set B has the elements 3, 4, 5. And this part I didn't talk about this yet. This is the intersection. So my intersection have 3. Intersection mean what I am highlighting in here. So the elements that are common to both set A and set B. Here what's common to set A and set B is 3. So I put 3 in here. So that's my intersection. So since I have 3 here, I can subtract 3 from this side. So I cancel this out and I end up with 1, 2, 3, 4, 5. So again, no duplicates because these 3 got cancelled out. So cardinality basically look at the size of a set. So what is the size of set A? Set A have 3 elements. So the size of set A is 3. So this is 3. Size of set B, again we have 3 elements, which is 3. And my intersection, which is what's common to both A and B, just 1 element. So 3 plus 3 is 6 minus 1, which is 5. So the cardinality of A union B is 5. So that's the size of A union B. Another way to think of union is think about students who are major in computer science and other students who are major in mathematics. So my union would be all of those students, including the students who are major in both computer science and mathematics. So what's outside this set A and set B would be like people who are taking physics or chemistry and other majors. Another set operation is intersection. The definition is the intersection of set A and set B denoted by A intersect B is the set containing those elements in both A and B. So this is saying set of all x's such that x is in A and x is in B. So which mean elements in both A and B. So things that are common to both A and B. Something to note is if the intersection is empty, then A and B are said to be disjoint. So I'm gonna show that later on. So meaning set A and set B does not have any elements in common. So no common elements. So let's say you have this example. What is the intersection of these two sets? Set A have the values 1, 2, 3 and set B has the values 3, 4, 5. So okay, A has these elements 1, 2, 3 and B, set B has the elements 4, 5, 3. These three elements. So the intersection is what's common to both of them. So your solution is 3. You just write it like this. So what about this example? So set A have the elements 1, 2, 3 and set B has the elements 4, 5, 6. So what would be your solution in this case? So if you draw it in a Venn diagram, you will have two sets like that and there are no common elements. If you notice here, there are no common elements between these two sets. So this set A might have 1, 2, 3, set B have 4, 5, 6. So nothing in common. So in this case, I'm going to say my solution is the empty set. You can write it like this or you can write it like that. In both cases, this means your solution is the empty set. So if you think about the previous example, we talked about students who are major in computer science and students who are major in mathematics. So what would be the intersection? So the intersection would be students who are major in both computer science and mathematics. Next set operation we're going to look at is called complement. So the definition of it is if A is a set, then the complement of the set A with respect to U denoted by complement A is the set U minus A. U is the universal set. So basically a complement of a set means any element that are in the domain or the universal set that are not in the set. So which means this shaded area you see in here, not including set A. So I have the universal set here, U. So I am subtracting set A from it. So when I take out set from my domain, so all of this shaded area is my answer. This is kind of like not P of X, where P of X is any element in set A. In some books, you may see a complement of A with this symbol. But in this class, we can use this symbol. So let's use that same example we've been using so far. I have my domain my universal set and two sets, set A and set B, and set A have the elements 1, 2, 3, set B has the elements 3, 4, 5, and outside of set A and set B I have 8, 6, 9. And what would be the complement of set A? So the complement is going to be everything that's not inside this set A, everything outside set A. For example, all the shaded area I have in here. So my answer should be everything outside set A, which does not include 1, 2, and 3. So my answer is 4, 5, 6, 8, 9. So everything which are outside set A. What would be the complement of B, set B? So which means everything that does not belongs to set B. So in this case, my answer is going to be 1, 2, 6, 8, 9. 1, 2, 6, 8, 9, which are not included in set B. So what about this one? A, complement of A union B. So what is the A union B? Meaning everything in set A and set B, including what's common. So complement means everything that does not belongs to set A or set B, both of them. So in this case, my answer is 6, 8, 9. This result 6, 8, 9. Right. So what about A intersect B? So what is the intersect part here? Which is this part where I have 3. So what's common to set A and set B? That's my intersection. So in my case, if I want to see the complement of the intersection, I get 1, 2, 4, 5, 6, 8, 9, which means everything except this element 3. Last set operation we are going to look at is difference. So here's the definition. Let A and B be sets. The difference of set A and set B is the set containing the elements of set A that are not in set B. This is like a normal subtraction question. Here I am looking at A minus B. So X is in A, but X is not in B. So whenever you do a subtraction like this, it's saying everything is in A that does not include in set B. Basically what I'm doing is, if set A contain any elements that are in set B, I am subtracting them out. So let's take that same example we've been using. So I have two sets in here. So what would be A minus B in this case? So your answer should be 1 and 2. Set A has the elements 1, 2 and 3, but 3 belongs to B. So when you subtract out, you're gonna get rid of these 3. So you end up with just 1 and 2 as your answer. So what about if you have B minus A? So B has the value 3, 4, 5, but 3 belongs to A. When you subtract A out of B, 3 has to be taken out too. So you end up with 4 and 5. I couldn't include numbers like 6, 8, 9 because those numbers were not included in set A or set B to begin with.